Hey everyone, today this is 9.5 properties of and conditions for kites and trapezoids. So what is a kite? Let's start with that one. That one's kind of weird. A kite basically is a shape that looks like a kite. Um, Notice that kites are symmetrical, right? So we can get kind of fancy with our definitions and say it's a quadrilateral with two distinct pairs of congruent consecutive sides, so that PQ is congruent to PS. QR is congruent to SR, that sort of thing. Or you could just recognize that, hey, there's one line of symmetry here. It's a reflection. There are two congruent triangles that share a side, like this sort of thing. Right. So here's one triangle. Here's the other triangle, and then pretty much everything on the green and the red triangle is congruent to everything on the blue triangle. And that's all our properties here. So we could say that this angle is congruent to this angle. We could say that this side's congruent to this side. This side's congruent to this side. We could also say, fortunately, that the diagonals are perpendicular to each other. And I think that's pretty much it. Oh, and then they also one of the diagonals is bisected. Right, this QS diagonal gets bisected. Should be pretty clear that PR is not being bisected. But the angle P here is being bisected. This angle is being bisected. Again, we can think of it as our two congruent triangles. So all the angles are congruent, all the side lengths are congruent between those two triangles. And that kind of gives us all our properties of kites. I was supposed to cover these up. Well, I'll just give you the answers. So we have, if we want to find the measure of angle ABE, A to B to E, we know that, well, okay, this is a right triangle. I'm missing some info here. Sorry. We know that one of those angles is 32 degrees, right? So we can figure out that that BAE, so B to A to E, I think it's this one is at 32 degrees. So therefore we can calculate that this top one here is 58. Boo, boo, boo. Just because we know it's supplementary to the other one. Okay, on to trapezoids. There are two types of trapezoids, right? Hopefully you guys know what a trapezoid is. It's where you have one set of parallel sides and then the other sides are congruent. Or not necessarily congruent. If it's an isosceles trapezoid, then those sides are congruent. So our example here, these two bases are congruent. And then it should be a parallel mark. So these bases are parallel to each other, and then we have two legs. If it's just a non-isosceles trapezoid, the bases are parallel. The legs can be any length, essentially. So we have some properties for trapezoids. Essentially, a regular trapezoid, there's not a lot we can tell about it. We can do some information, right? You have all the parallel line properties, that sort of thing. But once we have an isosceles trapezoid, then we can make some comments about it. So it says that each pair of base angles is congruent, right? So this angle is congruent to this angle on an isosceles one. If a trapezoid has one pair of congruent base angles, then the trapezoid is isosceles, essentially the reverse of that, right? A trapezoid is isosceles if and only if its diagonals are congruent. I missed this one as well. And then finally, yeah, the diagonals are congruent, so this one is equal to this one, right? It's not true for this trapezoid here. Okay, just some examples. A railroad bridge has side sections that are trapezoids. AC is 13.2, so A to C. I'm just going to highlight it. Boop. That's 13.2. BE is 8.4. Boop, boop. So that's 8.4, and we need to find D to E. Well, we know that AC and BD are congruent because that's one of our properties of isosceles trapezoids. So since those are congruent, all we need to do is figure out the total length for, well, we know the total length for AC. We can calculate the total length of BD, right? So the total length of BD is 13.2 as well. And then we can subtract off the length of BE. So minus 8.4 gives us 4.8. Okay, let's try this one. There's algebra in this one. Find the value of x so that trapezoid EFGH is isosceles. So in order to be isosceles, this angle here has to be angled equal to this angle here, similar to these. So we have to just set these equal to each other. We can say 2x plus 21 is equal to 3x minus 4. So when we set those equal to each other, we can solve. So 3x squared minus 4 equals 2x squared plus 21. We can add 4 to both sides. We can subtract 2x squared. Leaves us with a single x squared here and a 25. What's the square root of 25? 5. Yeah. So we're not going to do negative value. Okay. See if you can do number 8 and number 9 real quick. So pause here. To give you those answers. So the first one's 104, the second one's y equals 4. That's all you have to figure out. Okay, last little bit here is just that if we have a trapezoid, any trapezoid, it doesn't have to be isosceles, there's a thing called a midsegment, right? So we have our two bases or our parallel sides. If you go midpoint to midpoint, if you connect those two midpoints, you end up with this midsegment that's also parallel. And the cool property about it is it's the average of the top base and the bottom base, right? So it's directly in between here, and so if this one's short, this one's long, it's going to be right in between. We just use our average formula, right? So we'll use some simple numbers. If this is length of 4 and this is the length of 8, we'll take the average of those two. That means this midsegment is a 6. But you should be able to figure out or know this trapezoid midsegment there. We can go ahead and use it. Do a quick example. Basically, we need to calculate what xy is. So we take the average of, sorry, you can't really see that. We take the average of 12.5 and 10.3. The average of those two numbers comes out to 11.4. Okay, let's see if we can do this one. This one's a little trickier. We have 8.3 here for this base. We have 9.8. So essentially we're saying the average is 9.8. 9.8 is the average of what two numbers? 8.3 and... Blah. So when you're not sure on these things, it's just an algebra problem. So you just, you write out the formula, right? So you say 9.8 is equal to the average, so 1/2 of KL plus JM. We know the value of KL. That's 8.3, and then we just go from here on algebra, right? Multiply both sides by 2, subtract 8.3, and that gives us 11.3. So we know that JM is 11.3. Okay, see if you can do this one. Hopefully got 12.6. My last little comment here is I am going to erase these. So just keep in mind if we have any quadrilateral, we talked about these ones here before, rectangles and rhombuses are both parallelograms. If a shape is both a rectangle and a rhombus, it is a square. If we have only one pair of parallel sides, then it's a trapezoid. Note here that all parallelograms fall under that trapezoid category. If we only have two distinct pairs of congruent sides, then it's a kite. So kites are kind of off by themselves. Okay, that's all I got. Have a good one.